Hi everyone, good evening. Can you guys hear me and able to see my screen?
Yeah, again.
Okay, cool. So today we are going to discuss very important concept in our training. So you have to be very much keen on today's session because you have to understand whatever we are going to cover today. You have to be very clear on the concepts. If not, it's going to mess up with a lot of things. So please try to focus on the session today. So in last class, we have seen what is VPC, what are the components involved in it, and what default VPC looks like, how the default VPC will be having a lot of components interconnected to each other, and how the internet connectivity workflow will be there inside the VPC. So today we are going to discuss something about network in VPC. So network, we measure these networks in terms of IP addresses, right? IP addresses and data flow in terms of packets, right? So today we are going to discuss how we are going to declare the IP addresses for a particular VPC when you are building a custom VPC in your AWS account, how you can declare IP addresses and how many IP addresses you required and how to calculate and get to know. So what are the key inputs that we have to give? So in general, what you know about IP address? So IP, the full form of IP is like Internet Protocol. Of course, everybody knows it. So Internet Protocol. And this Internet Protocol will be on two types. One is IPv4 and IPv6, right? And again, every IPv4 and IPv6, you can have public internet as well as private internet. So here you will be having public IP address and you'll be having private IP address as well. And same goes here, public, private. So now for VPC, what we have considered in terms of VPC, what we have discussed, VPC is like isolating the network resource, isolating the cloud resources in AWS in terms of a private network, which is the abbreviation of it is virtual private cloud. So for this VPC, let's say you're going to build a project, you're going to start your application deploying on your AWS cloud. The first basic work starts from VPC only. So first work, you got to decide how many IP addresses that are required for your servers where you're going to deploy the application and how many servers required. Again, that is dependent on how many IP addresses you are going to declare for VPC. And how we are going to declare this IP addresses to this VPC in the form of CIDR. What is this? CIDR, which we call it as classless inter-domain routing. Why this classless inter-domain routing? Let's see that. So let's see some examples of IPv4 address. So whatever I'm writing here, always remember guys, IP address of IPv4 is going to be separated by 4 digits and each digit will be separated by a dot. This you have to remember. And in each digit, you cannot go beyond 256. That means the last number from 0 to is 255, 0 to 255. You cannot go beyond 256. Fine. So let's see. So here in IPv4, we have 4 digits which are separated by 3 dots in between. And we can say one example IP address 10.0.0.0. This is one example IPv4 address. So now here, each digit we have, this digit, this and this, we call them as octet. What is it? Octet. Why we call it as octet? Because each digit weight, each digit memory or size that you can store here is 8 bits. What is it? Each digit weightage is 8 bits. So we have 4 digits. That means 4 into 8. So total IPv4 IP address size is 32 bits. So each digit is having 8 bits. So we call it as a octet. Okay. So now, so initially the first version that we have got from IPv4, that is from the internet protocol, which is IPv4. And we have 4 decillion IP addresses over the globe. What is 4 decillion? 4 million, 4 billion, 4 trillion. But we have 4 decillion IP addresses over the globe. I don't know how many digits for this. It's even beyond multiplied, a very huge number. So now the people, those who are using this IPv4, they are getting increased day by day. And that's the reason we have got a big bandwidth of IP addresses in terms of latest version, which is IPv6. And this IPv6 is not completely on to the market because no one is using this IPv6 addresses. I'm not telling no one is using. There are some applications still using this IPv6, which is the latest one. Why? Because most of the IP addresses which are dedicated for each and every server is picked up from this 4 decillion IP addresses. So these are getting finished. So in future, maybe 10 decades or 20 decades after, we can see this IPv6 is going to occupy completely into the market. For now, we don't need this. So IPv4 is what we are going to see in our entire AWS account. And now all the projects, the applications which are running in the market in every company, every domain, telecom, e-commerce, banking, retail, anything, supply chain, every application which are having IPv4 addresses only. And in AWS, we are going to work with IPv4 addresses. Right. So in this IP addresses, we have again different classes. We have class A, class B, class C, class D, class E, 5 different classes we have. But AWS is not going to consider these classes. We don't have to care about what class works for which IP address. That is the reason we call it as classless inter-domain routing. We need to understand the expressions and equations that we come up with classless inter-domain routing. So since we have already discussed, each IP address is having 4 digits separated by a dot, and each digit is having a size of 8 bits, and 4 digits accumulatively, you can consider an IPv4 address will have 32 bits of size. Again, we have 2 different types of addresses, right? Public and private. What is this public and private? What is public V4 public IP address and what is private IP address and why we need it? Okay, let me tell you. Let's say you have 2 VPCs, okay, or 2 networks on premises or whatever you call it as VPCs or network 1, and you have network 2. If these 2 networks, I might have deployed a lot of missions inside this network, right? If any mission in this network wants to communicate with any other mission in this network, they should have a public IP address connectivity. What is it? Public IP address connectivity. You cannot connect with private IP address. You can connect with private IP address, but you need to have on-premises VPN integrated with both the networks. Then only you can connect with private IP addresses. So once the network, even though these 2 are separate networks, and when you are integrating these 2 networks with the VPN on-premises, then we cannot consider that network to be a isolated network, because these two networks are integrated together and they can communicate each other very freely. And for that communication, we need to enable public IP address. And then what is private IP address? So if any of the two communications wants to communicate in between each other inside this network, then they don't need to have public IP address. Then they can communicate with private IP address. So that's way we diversify these two different types of IP addresses. One is public and one is private. And private IP address is more secure. In all the organizations, most of the applications will run with private IP address. And only admins, the backend servers, only the backend servers will run with private IP address, and front-end servers will definitely have a public IP address, and that will be mapped with a DNS, which we call it as domain namespace server. We are going to discuss this DNS in future. We have a service in AWS, we call it as route, and its default number is for port number is 53. That's the reason we call it as route 53. So we are going to discuss this service in future. So for now, this is not our concept. So in VPC, we are going to work mostly with IPv4 address, and we are going to define this IPv4 addresses, how many IP addresses I need in terms of CIDR range. Okay. Now, if you are considering about one single IP address, let's say one single IP address, if you need, you can just declare like this. Okay. One single IP address is fine. What if I want 10,000 IP addresses has to be declared? So that is where the CIDR ranges will come in. So we have to declare, when we have to declare 10,000 IP addresses, we have to put them in the form of a CIDR range, and the CIDR range looks like this. The IP address, which is an oblique of 16. So this is how we can declare the range. Here, the number 16 indicates the range of IP addresses. Right. Range means in general programming or in general terminology in software, range is something 0, 1, 2, and so on. Whatever the number, the range maximum number that you define, we consider it as range. So here, 16 is the maximum range. What is this 16? Is it only we are going to get 16 IPs? No, this is not right. So we have a formula called 2 power 32 minus n to declare how many IP addresses we are going to get for one single CIDR range, and how this formula has been built. Initially, I have told IP addresses is going to be separated by 4 digits, and each digit is separated with a dot, and each digit size is 8 bits. Okay. Each digit size is 8-bit, and accumulatively a single IPv4 IP address size will be 32 bits. So now let's say I have declared the CIDR range of 16 in this IP address, right? So now what I'm going to do in this formula, 2 power 32 minus 16, which is equal to 2 power 16. And you're going to get 65,536 IP addresses for your application. And why this 2 power 32? Because the IP address size will be 32 bits. And what is this n? The range of the IP addresses that you define. If you define 16 as your range, you are going to get 65,536 IP addresses. And why we have declared 16 here? That's the point. So each IP address of IPv4, we are going to get 32 bits, and you are allowed to declare the range something like this from 0 to 32. 0 to 32. So in AWS only permits from 16 to 28. Why this? Just remember, we have to discuss this in the end of the session. So AWS only permits 16 to 28. So the moment you go the number higher, let's say you have declared initially 16, you are going to get 65,000. And then you are going to go for more than this, 17, 18, 19, 20. This number will keep on decreasing. The moment you increase this number this number will keep on decreasing. At last, for 28, if you declare, you are going to get one mission. Sorry, 16 missions. 16 IP addresses. And if you declare 32 as a range, you are going to get only one mission. Fine. You know how to derive this. You have the formula 2 power 32 minus n. If you put this number, whatever the range that you declare in this formula, let me put it in this way. Let's say, for example, I'm declaring my CIDR range as this 192.168.0.0/32. Oh God, yeah. /32. What I'm going to do, 2 power 32 minus n. What is it? 2 power 32 minus 32, which is equal to 2 power 0. What is 2 power 0? 1. That means you are going to get only one IP address. Now, why AWS is giving only 16 to 28 IP addresses? There is an important point. The moment you declare one particular CIDR range, let's say you have declared this CIDR range. Let's say let me keep it as 16. Okay. And this CIDR range, what we are declaring is for VPC, correct? We are declaring this CIDR range for VPC. Again, we have discussed in the yesterday's class, the VPC is again subdivided into subnets. What is it? Subnets. VPC is again divided into subnets. Now, let's say I have 65,536 hosts that can be launched from a single VPC. Okay. So you can go for 256 IP addresses. That means you have to divide the 65,536 number of hosts between different subnets. So each subnet is going to get 256 IP addresses. Okay. So that is the reason for every subnet you got this 256 IP addresses, AWS is going to keep 5 IP addresses with them. They are going to reserve these 5 IP addresses with them. That means the moment you declare 256 as a CIDR range for the subnet, you are going to get only 251 IP addresses. So there is a calculation for it. So what standards that AWS provides us? Just declare your IP address, any of the format, either it can be 10.0.0.0 or 192.168.0.0 or 171.16.0.0. Okay, sorry, 172. So AWS is recommending for us, you have to follow only these 3 standards as these 3 IP addresses for your application. Why? Because we have discussed there are 4 decillion IP addresses in the market. All of them are public IP addresses. The moment you launch a mission, every mission you are getting a public IP address is going to pick from these 4 decillion IP addresses only. Out of these 4 decillion IP addresses, only these 3 IP addresses are there. So there is one act which has been declared on 1918, which we call it as RCF something. I don't exactly remember. According to this RCF Act of 1918, we have these 3 IP addresses which have to be declared on a private network. And obviously, we are defining our VPC to be a private network. That means we need IP addresses only from this particular IP address range. So now, let's say I have taken my IP address range as 192.168.0.0/16, which is my VPC CIDR. So when you have VPC CIDR, each subnet that you create inside this VPC you cannot declare lesser than 16. You have to go above 16. Why? Because the moment you go above 16, the number of IP addresses allocated to VPC will be 65,536 if you declare 16 as a range. The moment you go above 16, this number will keep coming down. That means, let's say your VPC volume is this much, and you cannot create subnet beyond your VPC volume, right? You have to create subnet within the VPC volume. That means if the VPC volume is having 65,536 IP addresses, out of this 65,536 IP addresses only, we are going to allocate for all the subnets. And we have to put the number equally. It's not a rule that you have to distribute the IP addresses in terms of equally. Again, that depends on a business requirement. But according to AWS standards, what AWS is giving us, allocate your network range distribution among the subnets equally. So now when you distribute it, what is the CIDR range that we have to provide for a single subnet? And we are providing this CIDR range for a VPC. What is the CIDR range that we have to provide for a single subnet? As moment that I'm creating a subnet here, if this is my IP address range, CIDR range, I'm going to go for 192.168.0.0/24, Y24. Then only you are going to get 256 IP addresses. Just calculate it, 2 power 32 minus n. That means 2 power 32 minus 24. You're going to get 2 power 8. You're going to get 256. And when you have 256, then only you can distribute these IP addresses equally among 200 subnets per VPC. Any questions till now? Any questions, guys?
That is 256. Among that, 5 is there, right? 5 is going
5
to the
will be
reserve.
reserved by AWS. 5 is going to reserve by AWS for one particular. Always the IP addresses will start from 0 to 255. That's what I have told,
Okay.
right? Each octet 0 to 255, right?
Okay.
The first IP address which is going to generate from the CIDR range, AWS is going to put it for the network address. What is it? Network address. And with this network only, all the network traffic flow is getting into the inside VPC. That's the reason AWS is going to put it this particular IP address for reserve. AWS is going to reserve this IP address with them. And the next IP address, as for following by, we are going to put it for the VPC router. So whatever the route tables that you create inside the VPC and you attach the VPC, all the route tables will be routed on basis of this IP address only. And the next one will be all VPCs by default will be enabled with a DNS resolution, which we call it as resolving the domain name system. Few people in this batch, they might be new about what is this domain name system and all. As soon as you type in the Google www.google.com, and this we call it as a DNS, which is domain name system, youtube.com, facebook.com, everything, which we call it as a DNS. So in the background, one IP address will be mapped with one DNS for our application. So as I said, so the second 0, which is for network address, 1, which is for router, second, which is for DNS resolution, third, which is going to be extra, that VPC is going to keep it with them for the future references. And the last one, which is 255, AWS is going to reserve with them for the DHCP option set. So what is the DHCP option set? We are going to discuss as part of the future of VPC. All right. So that's these 5 addresses will be reserved by the AWS itself out of 256. So that means you are going to left with only 251. Okay. So each subnet, you are going to have 251 IP addresses you are allowed to use. Rest of the 5 will be occupied by AWS. Is it clear, Yadu?
Yes.
Cool. All good. So now we have discussed what is the history of IP address and how it has been diversified. What is IPv4, IPv6, and how IPv4 again is divided into octets. What is it? Octets. And the octets size will be 8 bits and all the IPv4 size will be 32 bits. This is what we have discussed. Now we will discuss how we are going to allocate CIDR range for the VP address. And from the VPC, and from the VPC CIDR range, how we are going to diversify between different subnets. We'll see that. So now let's say the first IP address which I'm going to give to the VPC is 10.0.0.0/16. Guys, I recommend every one of you in this class, even though you are going for on work location, workspace, tomorrow if you are going for office, if someone is asking you what is the standard recommendation of the CIDR range for a VPC, this is going to be your answer. The rest of the two also there, you can tell them. This one. And the other one is, what is it? 128.0.0 something. Yeah, 16. Yeah, these three is the recommendations for your VPC. Even in real time, we are going to take only these three CIDR ranges. Go to any AWS projects in real time, look at your friends wherever they are working on. They are going to have all the VPCs with these CIDR ranges only. All right. So let me go back. So now 10.0.0.0/16. I have this for my VPC. Now I need to diversify this for my subnet. Now, as I said, we are going to get 65,536 IP addresses for this CIDR range. And I have these many subnets here, subnet 1 and subnet 2 and subnet 3, 1, 2, 3 and 256. And after the 256, it is going to start from 257. And after that, whatever the number, I'm weak in calculations, from there it is going to start after calculating 257. So now here in the subnet, to get the 256, what is that we have to decide? 10.0.0.0/24. What is it? /24. Everybody will do a mistake. Everybody will do a mistake. They will not allocate this IP address. Simply, they will allocate their first subnet IP address range as this 0.0.0.1/16. No, Ben, you can't do that. Why? Because as soon as you allocate 10.0.0/16, it is going to generate 65,536 IP addresses, out of which automatically you are going to get something like this. 0.1, 0.2, 0.3, everything is there. You are already occupied with this one. And again, how can you declare this IP address as a CIDR range for another subnet? No, you can't do that. And what is this number? Till how many number it goes up? Till which number it goes up? This series. It goes up only till 255. Okay. And so on 255. And then again, the IP address will start its factorial from here. So if this is going to be one subnet CIDR range, for the other subnet CIDR range, it's going to be 10.0.1.0 and then 10.0.1.1. So like this, 1.2, 1.3, and so on, it goes for 1.255. If this also completes, again, in the other octet, in the second octet only, it's going to go for 2.0. Again, 2.1, 2.2, 2.3, 2.4, and so on, 2.255. Till when it comes? Till where it comes? It comes from where this number has to be 255. That means what is the values that is going to come for your last subnet? Look at here. Your last subnet is going to come something like this: 10.0.255.0, again 255.1, and so on, 255.255. Got it? This is going to be your last subnet. In the last subnet, 200th subnets, you are going to get this many IP addresses. Your last IP address of this range is going to be 10.0.255.255 out of this 65,536 IP addresses. If you want, calculate 256 factorial. So what is 256 into 256? Calculate 256 factorial. You are going to get this. Not factorial, square. Now, let's see the simple calculation. Everyone will go wrong here. I don't want you guys to go wrong. Let's say I'm taking this IP address 10.0.0.0 as my VPC CIDR range. What is going to be my first subnet CIDR range? Can someone tell me? According to the calculation. Anyone? Yadu, Jovin, Binu.
10.16, right? 10.0.0.1. 1/16.
This is going to be your first subnet IP address, is it?
Yes.
Wrong. Any other tries? Okay, look at here.
4,
Yeah, tell me.
4, I think.
What is it?
From 4, 0, 1, 2,
0.
4.
You mean?
Mm.
Okay, no. I think you guys, okay, look at here. For VPC, the CIDR range is going to be something like this: 0.0/16. It is going to get 65,536 IP address. Okay. How these IP addresses are generated? Look at here: 10.0.0.0 and 10.0.0.1 and so on, 0.2, 0.3 and so on. It is going to be 0.255. This many CIDR ranges will come for your first subnet. For your first subnet, if you want these numbers to come, you need to declare your first subnet CIDR range as 10.0.0.0/24. Only when you give 24, you are going to allocate 256 IP addresses for one subnet. If you want, calculate with this formula: 2 power 32 minus n, which is 2 power 32 minus 24. How much? 2 power 8, which is 256. Okay. So for one subnet, when you get 256, your CIDR range has to be 10.0.0.0/24. I'm telling you clear calculation. There is no rocket science involved in it. Only when you allocate 256 IP addresses for a subnet, you are allowed to launch 200 subnets. That's all. Why? Because VPC range itself is, it can occupy 200 subnets, not more than that. If you want, you can request for AWS, they can increase the limitations. Now, what is the first CIDR range? This is the first CIDR range. And your first octet is completed. Your first octet is completed. Now tell me, what is the second subnet CIDR range? What I need to put here? Guys, give it a try.
Is it 1 dot?
Exactly. You're right. Who is this?
It's Bibina.
So 1.0/24. That means again here You're going to get 1.1, 1.2, 1.3, 1.4, and so on, 1.255. This is going to be your second subnet. Okay. So just calculate yourself. You will get the clear idea. This is going to be subnet 1. This is going to be subnet 2. How these diversifications are coming in. This is octet. One octet can hold 256 IP addresses if you are going 256. Your octet number cannot go beyond 255, 0 to 255. That means you have completed 255. And when you declare 65,536, that means you need to get this many IP addresses. When you have 255 in place, then how you can get this many IP addresses means 256 into 256. So second octet also should have 10.0.2.0/24. This is third subnet. And it is going to come like this 2.1, 2.2, and so on, 2.255. This is going to be your third subnet. Is it clear for everyone, or else you want me to tell again? Please tell me. If you don't understand this, you cannot work on VPC. I'm pretty sure about it.
Our side range will be 16 or 24.
16 is going to be VPC side range, Yadu.
Okay.
And each 24/24 that you are declaring is for subnet cider range. For both, you need to declare cider ranges, but for VPC, you are declaring the very bigger cider range. And inside this, you are going to declare within the VPC range only, which is /24. Let me draw a picture. You will be able to understand the outline. Let's say you have this as one VPC. Okay. And this VPC consists of 65,536. How this comes is 10.0.0.0/16. This is the side range of the VPC. Okay. So inside I have two subnets. I have many subnets. For each subnet, I need to get 256. One subnet, two subnet, third subnet, fourth subnet. So here I need to get 256 IP addresses, 256 IP addresses, 256, 256. So each subnet AWS is going to reserve 5 IP addresses. Here out of these 4 into 5, if you construct this architecture, AWS is going to reserve with them 20 IP addresses with them. So each subnet range, see, this is the bigger range, 16, which is going to get 65,536. For each subnet, you are going to declare the cider range, something like this, 10.0.0.0/24. This is one subnet, 10.0.1.0/24. And this is 10.0.2.0/24. This is 10.0.3.0, sorry, 3.0/24. You get it? So as soon as you fill the first octet, if the first octet is filled with 256 numbers, then you are moving to the second octet. See here. If the second octet also filled with 256 numbers, then you are moving to the another number, right? If it is moving, if this series is going to complete 256 IP addresses, then you are increasing the number here, which is again, you'll get 2.1, 2.2, something like that. So this is the bigger range for the VPC, and this is the ranges for each subnet. Any doubts still? Is it clear? I'm not going to go for hands-on VPC if you don't understand this. Cool, mate. Thanks for the confirmation. So this is done, mates. All we have seen how to declare the CIDR ranges. Just wanted to give the note points over here. So each octet, again, I'm alerting you guys with some points. IPv6 address is going to have 4 digits, which are separated by a dot. Okay. So each digit we call it as octet. So each octet is going to have 8 bits of size. So total IPv4 addresses, IPv4 IP address size is going to be 32 bits. Okay, it is going to be 32 bits. And the fourth one, AWS will reserve 5 IP addresses, 5 IPs for every subnet you create. Every subnet you create in VPC, AWS is going to reserve for 5 IP address. Yeah, that's all. These are the main key important points. So you just have to remember, and remember this formula. It is going to helpful for you in future as well. 2 power 32 minus n. So if you are getting one particular CIDR range, you need to implicate this formula so that you can get to know how many IP addresses you can generate out of this. All good. Let me go to VPC creation now. Hey, Yola, we are going to create our custom VPC now. So I'm in my AWS console. We are going to implicate this particular infrastructure. The 3-tier architecture. We'll try to build it now. So it's going to be something like this. I'm going to build a VPC on an outer layer. I'm going to build a VPC now. So inside VPC, I'm going to take 2 subnets, which is public, private. So yesterday we have discussed, you guys very clear what is public subnet and what is private subnet. I'm going to have an internet gateway for this public subnet and NAT gateway attached to this public subnet to maintain the single way communication. Okay. And this public subnet and this private subnet, they are going to communicate together with the help of a route tables. Okay, let me build this architecture. This is very simple. Let me go back to the console now. So I'm going to VPC section. Okay, this is my VPC section dashboard. You can see number of objects you have inside the VPC, number of resources. You have 1 VPC here, 6 subnets. Let me increase the font size. Yeah, you have 1 VPC, 6 subnets, 1 route table, internet gateway 1. Let's see all this. I'm in my North Virginia region now. So let me go to this VPC or let me switch to Mumbai region. I don't want this. So I'm going for VPCs. Create a VPC. Custom VPC. So yeah, I'm inputting my IPv4 CIDR block. I'm going to put my CIDR block range something like this, 0.0.0/16. Guys, remember, carefully observe. I'm not going to tell again and again. Please carefully observe. If you don't understand, ask the doubt here itself. So I'm going to give the name tag for VPC, declaring the CIDR range. I don't want anything. I don't want IPv6 as well. Nothing, all good. And here there is an option. Look at here, default tenancy, dedicated tenancy. That means AWS is going to host a dedicated network only for you. This means even though you terminate particular VPC, the network is going to be still there for you in the AWS data center. Again, you create a VPC, that network is going to be captured by your VPC. Just keep that in mind. What is the difference between default and dedicated? So for now, default is fine. No one goes for dedicated, by the way, because they don't need that kind of options. So create VPC. So I have created the VPC and I have declared the CIDR range. So now, just remember this DHCP option set, which we have discussed before. We will discuss about this. I'll talk about this later. So now, as soon as you create a VPC, look at the configurations here. You have the IPv4 CIDR range here, which is declared, and you have a route table. So that means, along with the VPC creation, by default, there will be two resources created. One is route table. The other one is access control list, which is a subnet level firewall. Okay, this is my first custom VPC. All good. Now let's go back and create the subnets. Click on the subnets. So I have 3 availability zones here. If you want to filter only for your VPC, let me select my custom VPC. This one just now I have created. I have selected this custom VPC, create a subnet here. So I'm going to drop down, select the custom VPC now here. Give this name as public subnet. And I'm going to choose my -1A as my availability zone. And this is what the CIDR range that we have declared for the VPC. And I'm going to put my subnet CIDR range 10.0.0.0/24. As soon as you give 24 here, it is going to show 256 IP addresses is going to be allocated for this subnet. If you want to increase it, just go about increasing it here, top and down. Okay, top and down. So 24 is my subnet range. So I have added a tag to my subnet. I'm going to give another subnet. So this is one subnet I'm creating. I'm adding another subnet here, add new subnet, and give a name this time. I'm going to go for public subnet. Okay, public subnet. This time, okay, let me add this subnet later because I want to show you some errors here. Let me add this subnet later. I'm removing it. Okay. What did I put? -2. Oh, I've not removed the subnet. I removed the tag. Okay, that's all good. Yeah, my public subnet, and I have chosen my availability zone 1A, the VPC CIDR block and subnet CIDR block. And it is going to show 256 is the number of IP addresses it is going to allocate for a single VPC subnet, and click on create subnet. Okay, a subnet has been created here, which is public subnet. So now let me create one more subnet, which is private subnet. Click on this subnet, create subnet, VPC, custom VPC, and I'm going to give the name as private subnet. I'm going to put the same availability zone 1A. And this time, look at here carefully, guys. 10.0.0.0. Again, I'm putting /24. Again, it is showing it is going to give 256 IP address. But when you create a subnet, what it is telling in the red color alert, CIDR range is overlapping with the existing CIDR range because you already created this CIDR. You already created a subnet with this CIDR. Okay. Now, even though if you try to put 1 in the octet 1 like this, it will not allow. See, the error doesn't gone. Even though you try to create, it will not create. It is overlapping with the existing subnet. Why? Because the subnet which I have taken is already captured with 1 IP address. Now, my octet 1 is filled. Now, I'm going to go for octet 2, which is 0 here. And now I'm going to put it as 1. All good now. And let me convert it into 0 because I want my IP address to capture from 0 itself. That's all. Now try to create a subnet. Click on create a subnet. Yeah, it's got created. Okay. So now look at here. I have public subnet, private subnet, 2 subnets over here, and each subnet is having these CIDR ranges. First octet is captured over here and second octet is captured over here. So now how can you know how many IP addresses has been allocated for each IP addresses? If you just scroll to right, you will be see available IP addresses. You have 251. But obviously you are going to get 256. As I said, each subnet five IP addresses is going to reserve by AWS. So that is the reason you got only 251 IP addresses. Okay. So now outer layer part is completed. Here we have created VPC and we have created this public subnet and private subnet. Now it's time to attach a route and a gateway for this public subnet. Okay. And we have to create a route table. By default, we have one route table here in our AWS. As soon as I create a VPC, I got a route table here. Let me go here, this tab. Yeah, I got a VPC, which is tagged to this particular route table. Okay. So now I need a gateway to get into my VPC, where I need to attach this gateway. So initially I have not created any gateway and I have not attached it to the VPC. So now here, look at here, there is an option called internet gateways. Go there and create an internet gateway. Select the VPC which you want to just give the name, custom IGW, and create the internet gateway. As soon as you create the internet gateway, it is asking to attach. Now it is in detached mode here. Look at here and go to actions, or you can click on directly here, it will attach. Go to actions and click on attach to the VPC. Select the VPC from here, custom VPC, and attach the internet gateway. Now the VPC is enabled with an internet gateway. Entire VPC, we have attached the internet gateway here. Okay, IGW. So now all good. So let me go back. So I have created internet gateway. Now I need to let this internet gateway to pass internet to inside the VPC. So what I discussed before, the public subnet should have the internet and private subnet should not have the internet. Now, if you go back to the subnets, you have one common route table for this subnet. Where is this? Yeah, this is the common route table, see, which ends with FAB5. This is the default route table. It's got automatically created the moment when you create your custom VPC. Now select this route table. Okay, I'm at this route table section. I've selected this route table. Now you have a lot of options here. This is what yesterday we have seen. And here you have details of the route table. This is what the VPC it got attached to. You don't have any subnet associations already associated with. Now go to the routes. You don't have any internet gateway. You don't have any gateway to pass internet to let into the VPC. So we got to attach any of the internet gateway here. So how to attach the internet gateway? So if I want to attach this to the internet gateway, then I need to make this route table as a public route table, because only public resources is going to enable with internet. So I'm going to put it as public route table. If I want a private route table, I'll create another one. Okay, let me create it later. For now, I don't have any routes associated with. So before associating any routes here, let me go to the subnet associations. I don't have any subnets too. Okay, let me associate the subnet. Let me click on edit subnet associations. Let me select my public subnet, click on public subnet and save the association now. So the public subnet has been allocated for this route table. Look at here, go to subnet associations again. See, the public subnet has been allocated. Now go to the routes. In the route section, what I'm going to do, edit routes, add route. What I'm going to do, you have to put this, because you have to allow internet connectivity inside the public subnet through the public route table. So here you have the source from where the internet should come. You have the option internet gateway. You have a lot of options, NAT gateway, network interface, peering connection, transit gateway. Lot of options are there. Here our option is going to be internet gateway. Let's click on this and select the internet gateway, custom internet gateway, right? Which we have created right now before, and save the changes. All good. So we have the VPC and we have launched one public subnet, this one, and this public subnet is attached with this route table, which is this one, and this route table is associated with the internet gateway. The public subnet part is now completed. Okay. Now, let me test the connection here. As soon as I launched a public subnet, what I'm going to do, let me go back to my EC2 server. EC2 service. On the console, go to the instances tab, create an instance, launch the instance. Let me put it as public server. Okay, public server. Amazon Linux is fine. I'm going to go for T2 micro. Proceed without a key pair. I'm going to connect it with my browser itself. Yeah, you have to edit this network settings. You have to select your default VPC. Sorry, custom VPC. You have selected the custom VPC, but here very careful. You have an option to select which subnet, public subnet. So by default, this option is disabled. Okay, by default, this auto assign public IP is disabled. You have to enable it if you want to connect into the server that you are creating now. If you want to connect into the server, if you are creating now, you need a public IP. So for that, you need to enable this. Every time you need to do this, no. Just go back to VPC console here, go to subnets and select your public subnet. Select this, go to actions, edit subnet settings. If you come here, you have an enable auto assign public IP address setting. Just enable this setting, save it, and go back here on the EC2 console. Just refresh the page again, public subnet refreshed. What's happening? No, it's not getting refreshed. Let me remove it and VPC reload. Ah. Let me cancel this because it has to reload the setting, right? So again, I'm going to go for launch the server. I'm going to put as public server, selecting Amazon Linux, T2 micro, proceeding without a key pair. And here I'm going to edit my settings. Go to the custom setting here, custom VPC, and this is going to be public subnet. Yeah, automatically it changed into enable now. Look at here. I didn't change anything. Now let me create a security group, which is public server SG. This is fine. And inbound rules are anywhere, and I can put it as my IP. Okay, so that's all. I'm good. I'm good with this as a SSH connection enablement. I have selected all the details. Now click on launch instance. The instance is being launched in the public subnet that you have created. Let me refresh this page. The instance is in pending state. Let it come up. It is in running state. Just select the instance. Click on connect. No key pair associated. That's okay. Let's go to EC2 instance connect. So we have the public IP address and let's click on connect. I'm able to connect to this particular server through the browser. Unable to connect. Ensure the network settings are configured properly. Okay, all good. Let me go back. Refresh the server. Is my IP address is not getting connected through the browser? That's what I feel. Let me go back to the security settings. Public SG, inbound rules, edit inbound rules, custom. I'll put as it is anywhere. And I'm going to go for create another thing, all traffic through my IP address. Save rules and go to instances. The status check is not completed yet. Let's wait for it. Now, one instance status is completed. Let me refresh. All good. Let's try to connect now. Now I'm able to connect to the EC2 instance. Let me close this. Now I need to edit my security groups again. Click on this public SG, come down. I'm going to edit this inbound rules. Click on edit inbound rules. Let me put it as All traffic is custom and this is my IP. All good. Save now. So now let me click on it. Okay, this is because the browser once again. Let me make it anywhere. Fine. So instance connect, instances connect, instance connect. Able to connect to the server. Ls, I can do some operations. I can just do ping google.com. I'm getting some output here. So just remember this, I'm able to ping the google.com. I'm getting some output. That means there is an internet which is coming into my VPC. Now, if you look at this, let me go to VPC console. I just wanted to show you one important setting over here. We have selected this VPC actions. Oh, sorry, select actions, edit VPC settings. You have an option here, enable DNS resolution. This is very, very important. If you don't have this DNS resolution enablement for your applications, you cannot resolve any DNS inside the servers that you are launching inside this VPC. What if I can disable this particular DNS resolution and save it? And go back to the server again. It stopped here, right? It stopped. Let me do Control C. Now try to ping again Google. Ping google.com. It's not able to get any data because it's unable to resolve the DNS. So only when you enable this option, which is DNS settings enablement, then only any of the server is going to enable or resolve the DNS resolution for you. So now it's okay. But is it that we cannot resolve this? Since we already got the IP address, we can definitely ask to connect from the IP address. Ping. Let me copy this IP address. Yeah. So you can connect through IP address. You can resolve the IP address. Why? Because if you don't have DNS resolution enablement, there is no need to, if you directly connect through the IP address, there is no need of resolving your DNS. Even though we have disabled this DNS resolution, still we are getting some data from the server. Okay. I don't want this. Let me re-enable my DNS resolution. That's okay. Save it. All good. So now we have created a server in my public subnet and we have seen how internet is coming inside the public subnet. Now, everything is done. Now we have not diversified the subnets, either it is public or private. So the public, we have just connected internet gateway and that we make it as a public, but the private is still not having internet connection. Okay. So now let me go here, click on this private subnet, route table. So here still we have internet gateway. That means same route table, right? So for both the subnets, we have same route table. So look at here, both the subnets, we have been attached with the same public route table. I don't want this. Okay. Let me edit route table associations. No, not from here. Let me go back to route tables. So let me create a private route table now. Private RT, select the custom VPC, create the route table. Route table has been created. Now go here, subnet associations, edit the subnet associations, select your private subnet since you want to diversify the private subnet. Okay. So now you have made the private subnet association for this particular route. But there is no any internet gate inside this route. You need to have an internet gate. What I said, for public route table, you have to attach it to public subnet and public route table will be enabled with internet gateway. right? If you select this route table, go to routes, public route table will be enabled with internet gateway, and you got to attach this public route table to the public subnet. So then only internet can come in. But how we can get the internet from private route table? Sorry, private server. If you want to get some internet into the private server, you need to have a gateway called NAT gateway. Okay, what is it? NAT gateway. Go to the route tables now. Select the private route table here. Deselect this one. I have selected private route table. Go to routes. I don't have any routes here. That means whatever the settings that we have seen till now, those comes under free tier account. Now we have to create a NAT gateway. This NAT gateway is a chargeable. As soon as you create, your lab is completed, you please terminate this NAT gateway. Don't keep in your account. Okay, let me create a NAT gateway. I'm just giving custom VPC NAT. Select the subnet. Which subnet I need? Which subnet I need to attach? You need to attach this for public subnet, not the private subnet. Okay, public subnet. And you need to get the elastic IP address. So elastic IP, we'll talk about this elastic IP later. You are going to get the dedicated IP address for your NAT gateway. Okay, let me create this NAT gateway for now. So the NAT gateway got created and it got attached to public subnet. This is very important question in the interview. To which subnet you are going to attach the NAT gateway, either for the private subnet or for the public subnet. This is for the public subnet. Always remember, even through the private subnet, you are attaching this NAT gateway. First, the internet has to come through the public subnet only. From there, you are going to take the internet to the private route table, sorry, private subnet through the private route table. Okay, so first you need to attach it to the public subnet. So secondary IPv4 addresses, monitoring, nothing, all good. The NAT gateway is created. Now let me go to the route tables. I'm going to the route tables now. Select the private route table, go to route section. Let me click on edit routes. Here also, for the internet connectivity, you got to give this. Okay. NAT gateway, right? Not internet gateway, NAT gateway. I have got the NAT gateway, which I have created. Save the changes. All good. We have completely done from the VPC and all the configurations is completed. Now we need to test the connection, whether we can connect to any private server, which is going to launch in the private subnet or not. Let me go to the VPC. Let me see all my settings in the resource map. Click on this resource map. Scroll up. Yeah, you have a custom VPC. You have public and private subnet. Public subnet is attached to the public route table. Private subnet is attached to the private route table. Scroll this aside, and yeah, public route table is attached with custom internet gateway, and private route table is attached with custom NAT gateway. All good. This is what the resource map is all about. It can show where it got connected to what resource. Now, CIDRs. Look at the CIDRs. This is the CIDR which I have attached to the VPC. Okay. All good, Benz. Now let me go to the EC2. Let me launch a server inside the private subnet. So click on launch instance. I'll just name it as private sub server. Come down. Amazon Linux is fine. T2 micro. Proceed without a key pair. Oh, I need a key pair for this because I need to do server to server connection. I cannot connect directly to the private server. I need to connect to the private server only through the public server, which we call it as jump box or bastion host. We'll discuss about that. For now, I'm going to create a PEM key. Let me create a new one. I'll just name as bastion and create a key pair, and it got created. Let me edit the settings and VPC, custom VPC. I'm going to select public subnet. I don't want any public IP address to be enabled for my private servers. Because I'm going to create it in the private subnet. All good. Create a security group. So here, careful while you're creating a security group here, where you can explore number of options from where you can attach security group internets. Okay, let me just name it as private SG. I'm just naming it as private SG. And from here, In the SSH, I'm going to give it as custom. And in the source, what I'm going to mention is my VPC CIDR range, which is 10.0.0.0/16, which is 16. This is what my VPC CIDR range. Any server which coming with this CIDR range can be able to let into my private server. Okay. All good. I don't want any other security group here. Launch the server. The server creation is completed. So now, initially we have taken a public subnet and we have connected to the public subnet. Now I need to connect from public subnet to private subnet. That means the key which attached to the private subnet, it has to be there inside the public server. Okay. The key which I have attached to the private server, it has to be present in the public server. Then only I can connect to the instance using the private key, which is PEM key. So let me upload my PEM key into the server. How can I upload? If you are using mobile Xterm, you can upload the local file into the server. But if you don't have such options, I prefer to take an S3 bucket. Let me go to S3 service. I have a bucket which is public here. Let me select this bucket, upload an object here, add files, and the PEM key which I have downloaded, which is there here, it is in the name of Bastian.pem, right? This one. Okay. I've selected and it uploaded there. Upload. All done. So let me close this. So inside my bucket, I have two files. One is this one, Bastian.pem. Let me click on this. For on all the objects, you have to make this as public using ACL, right? Click on this. Enable make public. Yes. Now, what I can do, just close this and select this Bastian.pem. I can go back, select this Bastian.pem, copy the URL, go to the server where you got connected already. Yeah, here. It's keep on pinging. Let me stop this. Okay, all good. wget. If you look at it, I don't have any of the PEM keys. I don't have anything. I'm just using wget command. Yeah, Bastian. I'm downloading this. Yeah, the key got downloaded. It says status code is 200. Okay. And do ls. I have Bastian here. So now go back to the instances. Select your private server and click on connect and go to SSH client. Use these two commands. First, you have to change the permission into 400. chmod. Copy the command and put it in the server. Where I have connected. I've connected here, right? Yeah, here. Now do SSH. Sorry, SSH-I. The username is EC2-user @ the server IP address. You can also fire this command as well. Both are same. I'm just using this. Okay, here I forgot to mention the Bastian host path. Bastian.pem. All good. Yes, I'm able to connect to the other server. Okay, so look at this. How can you confirm these two are different servers? Look at the IP address 10.0.159 and 10.0.0.153. So for public subnet, we have given 10.0.0.24. Private subnet, we have given 10.0.1.0.24, 1.0/24. Remember, this is how the IP address is going to be generated. Okay, so now here, let me do this way. Ping google.com. Yes, I'm able to get some internet into my private server as well. So now let me stop this, exit. I came to my public server. Here also I'm able to get some. Okay. Now we have seen a successful iterations. I'm able to get the internet from public server as well as the private server. Let me see some mistake situations. Okay. So I'm going to go back to the EC2 instance console instances. Okay, let me go to my VPC console. I don't want this anymore. Select VPC. Click on here. Now see what I'm changing all the settings now. Go to route tables. Okay, go to route tables. Here what I'm going to do, going to routes, I'm going to disconnect this NAT gateway now. Okay, let me go to edit routes. I'm removing this route and add route. I'm using internet gateway here as well. Internet gateway. So that means now my subnet is also public subnet, but still will I get an internet? Will I get an internet? Let me see. Go to the server. I'm in my public subnet. Let me connect to my private subnet again. Yeah, I have connected to private subnet. Ping google.com. Am I getting anything? This is where you need to understand the difference between internet gateway and NAT gateway. NAT gateway is only connected through the private one-way communication to the private servers, which means internet gateway is two-way communications. You are not getting internet outside from outside to the private server. But when you connect to the public server, you are getting internet to and fro. You can download and you can ping from outside and you can push something to the outside out of the server. Anything you can do. Nothing, right? You're not getting anything. Let's go back. Go to the server. Go to VPC console. In the route tables, edit routes. This is my private route table, right? Yeah, edit routes again. And remove this NAT gateway. First, let me attach the NAT gateway. NAT. Let me remove this first. Okay, let me go for NAT. All good. Save now. Now go back to console. Now go back to the server connect. See, it automatically started pinging. That means only from the public private servers, NAT gateway is the only internet bridge. Okay, and that internet is coming from the public subnet and where the public server has been launched. So here you have to observe the difference. We have not directly landed into the EC2 server, which is created here. We have first launched EC2 server here. From this server to this private server, you are using a route table in between, and this route table is whitelisted with this NAT gateway. This is what you have to remember. Okay. Any doubts, guys, till now? This is EC2 in the public. This is EC2 in the private. So you can use this EC2 as a bridge. It's a mediator for your local terminal to your private server. So public server is going to be a mediator. Then this public server, we call it as a bastion host, jump box, jump server. Don't confuse if someone is asking the question in the interview, what is bastion host? Bastion host is a mediator server from the local terminal to the private subnet or private server. That's all. Any questions? Understood? Not?